Hey folks, I just wanted to say a couple of bits and pieces about Lab 6 if you're gearing up for that. So again, essentially for Lab 6, you're given two choices. You're going to create a branch of your project. So this is going to be a Lab 6 branch, and do make sure you put this stuff in the branch so it's not polluting your main project submission. But the idea is you've got two choices. Either in this branch, you can set it up so that all of your strings, all of your characters, all of your text handling is Unicode based instead of just straight ASCII based. Or you can set up a simple GTK interface for your project so that it's getting the user input through GTK and producing output for the user through GTK. So either one of those is okay. I don't mind which you pick. I just want to run through, touch base again on a couple of the mechanics for doing that. So just in terms of playing with the Unicode side of things or playing with the GTK side of things. So I have stuck in a link there with some code examples and make files and things for the GTK, so you can browse through that. I'm going to talk about the Unicode side first. The Unicode side is probably a simpler thing to do. So let me just pop up my beastie here. So for Unicode, essentially all you're doing is making sure that all of your strings, all of your character arrays, all of your chars are using wide characters instead of the straight normal ASCII characters. So what we'll do is include the CW char and the clocale is the libraries that we'll add to support this. We'll set up our display so that it properly handles our Unicode output when we generate it using the set locale. So your set locale, LC all, and I'm just going to use the defaults for most of the other settings. Then in terms of the data types, most of the functions in both the string library and the IOStream library are already set up to have variants that support our wide characters. So there's a WCOut for outputting our Unicode strings, WCIN for reading them in, there's WString for a wide string type instead of regular strings, a WCHAR-T for wide characters. So all of this stuff is provided for us. It's just a matter of switching all of your characters, all of your character arrays, all of your strings to the new wide format. So for the most part, things work reasonably simply other than that. If you actually want to get some special Unicode symbols and embed them in your prompts and that kind of thing, you can do it by code. So just take the Unicode code for the character you want and stick it in a WCHAR-T variable, and that will print out the smiley, for instance. When you're using literals in your Unicode programs, you want to precede them, well, Unicode characters or Unicode strings in your program, you'll want to precede them with the uppercase letter L to indicate that this is a wide char literal. So here, if I've got a hard-coded string in my program, I precede it with an L. If I've got a hard-coded, I didn't stick a hard-coded char in here, but same thing for the single quotes. If you've got a single-quoted char, you stick the L in front to indicate that you want a wide char. But other than that, things should work pretty normally. But it does mean you've got to go through all of your input and all of your output handling functions to make sure that you've updated this appropriately. So there's a fair bit to do, but none of it's terribly complicated. All right. So that was the Unicode side of things. For the GTK side of things, let me bounce into my other directory here. So I just wanted to run through an example of actually passing some information to a function handler. So again, the chunk of code I've got here is based off of the example that's in the GTK discussion there. So in there, you'll find somewhere down at the bottom a sample make file that shows you how to compile appropriately for GTK. And I think the example that I'm pulling here that I'm going to go through in just a sec is based on this simplistic C++ hello world. So you can grab the code for that and have a look at the source if you like. But what I want to do here is to show you an example of a program that our main routine is going to pass information to one of our event handlers to actually play with it a bit. So let's see what we've got here. So again, we include our GTK library. I'm going to have information that I can pass off to my different event handling functions that's got, a string for a username and a count of how often a message has appeared, just so I've got something so I can show the event handler manipulating the data as it runs. So I'm going to have this function is eventually going to be the one that gets called when I click on a button in the little window that I present. And so what's going to happen is it's going to get past one of those structs that's got a username and a count inside it someplace. And so when the user clicks on the button, this function is going to get called to handle that event. It's going to print the name that it finds in this, and it's going to update the count and print that as well. So what we have to do, again, because this G pointer is a generic GTK data type that's basically a glorified void pointer, what we're going to do is take that and say, okay, well, I'm going to cast that pointer back to the user data type that I was expecting. So a pointer to one of these beasties. So I'm casting it back to user data, storing it. I'll double check and make sure they didn't pass a null pointer. And then I'm just going to go through and print out the count that they passed, so my uinfo count, and the name that they passed. So I've got that stored as a string, so if I'm going to print it out using gprint, the old printf style, I've got to extract the character array portion of that. So that's why the .c_str on the end here. So I'm going to go through and print the username, the count and the username, and then I'm going to bump up the count by 1. And again, since this is getting past a pointer to wherever that data is, this is actually incrementing the count off wherever that data came from. So I'm going to have this event handler. I'm going to have another event handler that shuts down the program, and I'm going to connect that to the, if somebody clicks X in the corner of the window. And usual idea, I set my main routine up to accept parameters. I use my GTK init to fire everything up in the beginning. I create my top level window that's going to be the container for this whole thing. I'm going to set a border around it. And if somebody clicks the X up in the corner there, I want to trigger the destroy event. And that's going to call, so I'll set up a callback to call that ended all function that just runs the routine that shuts down GTK. So I'll set up a button in my window that's just going to be a little hello world button. And so I create this new button, I add it to my window, and then I'm going to create one of those user data items. So I'm going to create my info. It's going to have me as the username and 1 as the count so far. And what I'm going to do is connect the button click event in the button that I just created to that handling function that I created a few minutes ago, my hello function. And when that gets called, I want it to be passed a pointer to my info here. So this the address of my struct here is going to get passed off to the event handling function every time it gets called. So when somebody clicks on the button, it's going to call the hello function. It's going to pass a pointer to this myinfo thing off to it, and that is going to go off and again print the name, the count and the name, and increment the count. So essentially that's what's going on here. And I just want to show that this actually works. And of course at the end we say, okay, well I better show the button, I better show the window, and then start GTK running. And that's going to take the event handler from there. So that is the theory. Let's make sure this is up to date, and we'll try running the beastie. And so there, up in the corner, let's expand this a little. We get our initial hello world button, and I've got my little X up there. And if I click on this, the printf is just printing to the screen, to the terminal. So it's got my count as 1, me as the name. I click it again, count has gone up, so I can do this as often as I like. And eventually when I'm bored, I can click this and it will call that main quit routine. And there we go. So we do actually have something functional. Again, I just wanted you to see the fundamentals to be able to pass data around. Again, I do recommend going through some of the examples that are in the code snippets there. Do make sure you've updated your makefile appropriately, and we should be good to go.